Lesson 3, RT4, we are going to talk about when we use the law of sines, the law of cosines. Let's review real quick. When do I use the law of sines? All right, this thing, sine of A. What'd you say? Side angle pair, right? So if I have a side, I'm given a side, right? Like let's say this is 12, and I'm given that this angle is 41 degrees. That is a side angle pair. Now I need more than that. I need one more item. Let's say I have this side is 10. Right? Then I could use that to find the measure of angle B. If I have a side angle pair, I can work through using the law of sines. If I don't have a side angle pair, then I'm going to use law of cosines. And the law of cosines can be used to find a side or an angle. What would the scenario be if I wanted to find a side? Well, I'd have an angle, let's say 79 degrees, and I'd have two sides. Right? To find a side, the scenario you'd be given is side angle side. To find an angle, what would I know? Yeah, you got it. No, you got to have more than that. Three sides, yeah. Okay, to find an angle, you'd be given all three sides. How many times should you ever use the law of cosines? You should never use it more than how many times? Once. If you use the law of cosines once, let's say we use it and we find this angle right here to be, 84 degrees. Now do I have a side angle pair? Yes. Now I can use the law of sines until I complete the triangle. Right? So you should only use the law of cosines once. For multiple reasons. One, because then you can use the law of sines, and two, because it's a headache. There's a lot more algebra to the law of cosines. Okay, let's get started here and just take a look at a few examples. Okay, do I have a side angle pair? I do, except what angle am I given in there? A 90. So in that case, I'm going to use right triangle trig. What would that be? That'd be SOHCAHTOA. Okay, right triangles, you should always use SOHCAHTOA. Always.
Oh, I get it.
Okay. In the second one, am I given a side angle pair? Yes, I have this side angle pair here. Is it a right triangle? No, not that I know of. So in this case, I would use law of sines. I would use law of sines. I have a side angle pair. How about the third one? Do I have a side angle pair? No. Do I have a right triangle? No. What do I have here? Side angle side. That tells me law of cosines. Would I be finding a side or an angle in that problem? Yeah, I'd be finding this side x, right, which we would call little c. Okay, and the third one. Is that right triangle trig, law of sines, or law of cosines? Yeah, it'd be right triangle trig. Why? Because it's a right triangle. Okay, let's keep moving. Law of sines or law of cosines here? Law of sines, I have a side angle pair. So I'd use law of sines here. Okay. Oh, I see a right triangle. I'm going to do all right triangles, right triangle trig. Okay, let's see what other right triangles I have down here. I have no other right triangles. Okay, law of sines or law of cosines on the next one? What is this? A side angle pair? Law of sines. Okay, on the next one? Law of cosines. Yes, I have side angle side here. So that'd be law of cosines. I'm going to abbreviate now using an S or a C. Okay, the last three. Sines or cosines? Do I have a side angle pair? No, I don't. What am I given? I have side, side, side. That would be law of cosines. I said I was going to abbreviate. No, I'm not. That's cool. Okay, here I have a side angle pair. That'd be law of sines. And the last one would be what? Law of sines as well. Look, side angle pair. Should we set up one of these last three? You want to set it up? Okay, let's do this one over here first. What are all these little? Oh, those are little Blackhawks. If you zoom in on that, I think those are little. That's the Blackhawks emblem. Yeah, and I think I have messages in there. I don't know what they say though. Doesn't matter. I can't. You can.
Can't zoom in on it?
Oh, he's focused on his pretzels. Okay. Law of cosines to find, what am I finding here? An angle or a side on this bottom left portion? An angle. So law of cosines to find an angle says this. Okay, so let's label some sides and angles. Which angle are we trying to find? Angle B, right? So I'm going to call that angle C. You can do that? Yes, I can. So a side C would be this 390. What does A have to equal? Side A. What does side A have to equal? Rhetorical question. It doesn't matter, right? A and B are interchangeable. A and B are interchangeable. I'm going to go A here. I'm going to go B here. So I could do a direct substitution to find angle C. I'd do the inverse cosine of A squared plus B squared minus C squared over 2 times A times B. Let's pause real quick and see if we can calculate this. My suggestion the other day was to do this. Figure out what the numerator and denominator are first. I get a large number in the numerator. 114,800. In the bottom I get 266,000. Will somebody confirm? 2 times A times B in the bottom. When I do the inverse cosine of that stuff.
Wait, so after this, do I have to do another parenthesis right here? Because I didn't divide it by
No. Okay, then we got a problem. You guys, what I would do, like I'm doing right now, is I would calculate numerator first. I would calculate denominator second. I would plug them into an inverse cosine as a ratio, and I get 64.43 degrees. Okay, let's set this last one up here for spatial reasons. I'm gonna what did I say here? Sine of A over what? 362, right? It's the side across from A. Is equal to the sine of B. Well, I know B is 63 degrees over. Yep, thank you much. Now what do I do? Cross multiply, correct. 362 times the sine of 63 is equal to 415 times the sine of A. I'm trying to isolate that angle A so I can get it all by itself. I'm going to divide both sides by 415. That'll get me one step closer. So the sine of A is equal to all of this stuff. All right, so what do I do to find an angle? Inverse. Well, not cosine, right? This is a sine. Yeah, so I'll do the inverse sine. So the measure of angle A will be the inverse sine of 362 times sine of 63 over 415. All right, let's try that on the calculator. Are you getting 51 degrees? Excellent. I'm rounding because it's like 51.006 or something like that. Okay. Just be careful with your calculations. I think on the test what we'll do is probably say, hey, round to the nearest whole number in almost every case. I don't like how ambiguous it can be when we say round to 1 decimal place, all that stuff, because then we get issues. Okay, so I would just plan for whole numbers answers. That would be it. Now, if I wanted to solve the triangle, I know that this angle now is 51 degrees. So, yes or no, if I added 51 and 63, that'd be 114. Yeah, 114. So that would make this angle 66. Right, and now I can use the law of sines again if I wanted to find that side C. Okay. So you should only have to use the law of cosines once, like we did over there, and then you could use the law of sines to find the rest. If I'm using the law of sines, I might have to use it twice, plus a little bit of addition, using the triangle sum property of 180. And that's the lesson. Pretty good. Law of cosines, law of sines. You got some time to work. Plenty of practice problems on the slides to come. Like, subscribe, comment below. $9 to GNC to the 100th sub.